This is Mr. Beck Does Your Homework. This is physics homework number 23, question number 6, 7, and 8. Consider the circuit in the figure. Well, the circuit in the figure, I've got a battery. I've got current leaving the battery. Well, it doesn't matter, but I'm going to say the current flows this way. It splits. It can flow through either this resistor or this resistor. When it gets over here, those two paths come together, and then all of the current flows through this last resistor. I could also trace it this way. All of it goes through there, and then it splits. But usually we go flow from positive to negative. Find the current in the 2 ohm resistor. I want to find the current down here. Conveniently, that's the same as the current that leaves the battery, and the same as the current that goes back into the battery. So if I had an ammeter on either side, I would measure the current. So I want to find the current here. I need to find the current of the battery. To find the current of the battery, I know the voltage of the battery. I need to find the entire resistance faced by the battery. So I've got to combine these 3 resistors. To combine those 3 resistors, I notice that these 2 are parallel, so I can take a single resistor and replace those 2 with a single resistor that is equivalent to them. So that resistor over here is going to be a parallel combination of these 2 resistors. So there I've got a 10 and a 4. So I'm going to call that R1 because it's my first combination. So my R1, actually, since it's parallel, I'm 1 over R1 equals 1 over 4 plus 1 over 10. So when I do 1 over 4 plus 1 over 10, I'll get an answer. I have to 1 over that to get R1 by itself, and that's going to give me R1. Now I'm going to have 2 ohms here and R1 there. If I add those together, they're in series because the current that goes through one has to go through the other. So now I'll get R equivalent for the whole circuit, and that's going to be R1 that I calculated here plus 2 ohms. So that'll be my equivalent resistance of the whole circuit. Now I can finally find the current in the 2 ohm resistor because the current there is going to be the same thing as the total current leaving the battery, and that is going to be I is V over R. So it's the voltage of the battery divided by the equivalent resistance of the whole circuit. So for me, that's going to be 34.5 volts divided by whatever this R and Q was. That will give me the answer for the current in the 2 ohm resistor. My next step says find the current in the 10 ohm resistor. Well, where was that 10 ohm resistor? Turns out it was right here. I'm not sure because I'm going to have that current flowing and it's going to split. Some of it's going to go this way. Actually, more is going to go through the easier path and less is going to go through the more difficult path. But I need to find the I need to find the current here. My trick there is to find the voltage across this resistor. And since these 2 are in parallel, the voltage here and the voltage here would be the same. And if I look at this resistor R1, it would be the same as the voltage here, because I'm really finding the voltage from this point to this point. So here, it's either that path or that path will bring me down that voltage. Here, it's just across R1 will give me that voltage. Now, I can't find that directly. Actually, I can find that directly. Since I know R1 from this, since I've solved for R1, I know the voltage across R1, so I'm going to call that my voltage across R1, is going to be V equals I times R. It's going to be the current through R1 times R1. So it's going to be that current times that resistance. Well, what's the current through R1? It's the same as the current that leaves the battery. So in series here, all this current has to go through R1. So since I solved for it already, that's I total, is going to be the same as I R1. That current going through this resistance will give me that voltage. I'm not quite there yet. Now I know the voltage there. If I know the voltage there, that's also the voltage here. So now if I want the current going through the 10 ohm resistor, it's going to be this voltage, this resistance. So my current through the 10 ohm resistor is going to be the voltage that I just figured out. That's the same as the voltage of R1, right? Divided by 10 ohms. So now I'm going to get, so I'm keep on going back and forth with Ohm's law. Now I've got the voltage here divided by my 10 ohms, and that'll give me my current going through the 10 ohm resistor. Now it says find the current in the 4 ohm resistor. So now I know this current, and I know the total current. I'm going to use a trick because I know that my total current leaving the battery is going to be the current that goes through the 10 ohm resistor plus the current that goes through the 4 ohm resistor. So if I know the current that leaves the battery, it's going to split. Some of it is going to go this way, and some of it is going to go this way. But that total has to be the total that left the battery. Since I know that from earlier on, I've calculated my total And now I know my current through the 10. Now I can use that to figure out the current through the 4. So my total minus that will be this. The other way I could have done that is say that my current through the 4 ohm resistor is going to be the voltage R1, right? Remember, it's this same voltage. That voltage divided by 4 instead of divided by 10. And that will be a second way to confirm that you're getting the right answer.